Good morning, students. Today we will study about black body radiations and explanation by Planck's quantum theory. The first question that rises is, what is a black body? Black body is a perfect black, that when radiations of any frequency will fall over it, it will absorb all those radiations and that body will emit the radiations of all frequencies also. It means that a black body absorbs all the radiations that are incident or falling on it. When a black body is heated, it emits the energy in the form of radiation. So when a black body such as the example is iron rod, when that is heated in a furnace, it undergoes a series of changes in color, that it becomes red, then yellow, whitish. It means as the temperature changes or increases, there is change in color. Now we will study in detail about it. Why there is change in color? Suppose this is iron rod. When it is heated, it will emit radiations, that is energy. When these radiations are allowed to pass through a slit, these are electromagnetic waves. Suppose first temperature is T1. We are heating this iron rod at some temperature T1. So when it will become hot, it will radiate energy. So when we will pass these radiation through a slit and then allowed to pass through a prism, and here we will observe that what will happen on screen. So when radiations are coming, suppose this is the incident radiation, so what will happen? The white energy splits into different colors that we will observe here, different colors on the screen, and you can learn these radiation. A trick is, that is Behavior. So you will observe that there is maximum deviation for the V, which indicates violet color, I for indigo, B for blue, G for green, Y for yellow, O for orange, and R for red color. So there is maximum deviation for violet color and minimum deviation for red color. There is inverse relationship between the deviation and wavelength. Maximum deviation, minimum wavelength. Inversely, you can also say that maximum deviation, maximum frequency, that is, frequency is inversely proportional to wavelength. That is why you might have seen red color on signals. That is, we are using red light because there is minimum deviation in the wavelength of red color. So maximum deviation, minimum wavelength. So after that, what happened here? A device is used to know the intensity of these radiations, and by measuring the intensity we can also measure the associated energy with these radiations or with these colors. So suppose we are using it from red to violet. So what were the observation? When a graph was plotted between wavelength and energy at constant temperatures, it means when temperature is T1, after when temperature is increased T2, T3, it means T1 is greater than T2 is greater than T3. Suppose we are taking three temperatures, different temperatures. So it was observed that when temperature is T1, then wavelength, the value of wavelength was somewhat here, and energy was minimum. When temperature was T2, then wavelength was somewhat here, and the curve was, it was something like this. At T1 it was like this, at T2 it was like this, at T3 it was like this. So this line where the value of wavelength is maximum, we are denoting it by lambda max. At T1 lambda max, T2 lambda max, T3. So we observe that lambda, that is wavelength of red at T1, is maximum for lambda of yellow color, that is at T2, and is greater than for lambda for other color, that is when we are going down, that is for Vibgyor, as we are moving from violet to red color, wavelength increases and frequency decreases. So at different temperatures there is different value of lambda, and the product of lambda and this temperature is a constant value. That is, when this lambda for particular color is multiplied by that temperature at which that color exists is equals to a constant value, and this value is 2.9 into 10 raised to power minus 3 meter Kelvin, because lambda is in meter and T, that is temperature, is unit is Kelvin. So This equation was called as Wien's displacement law. And the importance of this law was you can measure the wave coming from the celestial bodies. For example, if light is coming from any source, if you know the lambda value, then you can calculate by putting the value of lambda and that constant, then you can measure the value of T, that is how much temperature is associated with that body. Now next is photoelectric effect. What is photoelectric effect? Photoelectric effect is ejection of electrons. When a photon, photo stands for the photon, that is light. When one photon, it is denoted by h nu, that is energy, that is photon strikes a metal surface, there will be ejection of electron from that metal surface. This ejection of electron when a photon of light incidents or strikes the surface of metal is known as photoelectric effect. Now question is every photon can eject electron? No, not every photon can eject electron. Only those photons of light having a minimum amount of energy which is required for the ejection of electron and or the frequency that is required for the ejection of electron. That frequency is called threshold frequency. Threshold frequency. It is denoted by nu naught. Is required for the ejection. That is the minimum frequency. And because we know that metal, there are atoms in metal, that is electrons are revolving around the nucleus in an atom. Okay, these electrons are bonded with the nuclear force. In electrons, these are revolving because of the nuclear force of attraction. It means there is some binding energy, that is binding energy is there, that energy which is responsible for holding this electron in this atom. So unless we don't have that much amount of energy which is required, that is called threshold energy, so that this energy will overcome this energy, only after that electron will eject. It means threshold energy must be greater than binding energy, only then electron will eject. And we know that E, that is energy, is directly proportional to frequency. Energy is directly proportional to frequency, that is frequency of striking photon. It means kinetic energy is also kinetic energy also depends upon frequency, and frequency is how many wavelengths passing per unit time, that is called frequency. Kinetic energy does not depend upon intensity. Intensity is the light radiation energy. Now this theory, that is Planck's quantum theory, it was in contradiction of the wave theory, because according to the wave theory, the energy of radiations is directly proportional to the intensity, and photons of any frequency could have resulted in the photoelectric effect by simple increasing their intensity. So Planck's quantum theory was not go with the wave theory of radiation. However, the photoelectric effect can be explained with the help of particle nature of light, that I have told you, that E is directly proportional to nu, so E is equals to h nu. That is binding energy, that electrons will eject only when the threshold energy is greater than the binding energy. So energy of incident photon, energy of incident photon h nu, that will equals to work done, that is equals to h nu naught, plus kinetic energy, that is half mv square. So conclusion of this is, if energy is less than threshold energy, there will be no ejection of electron. Only ejection of electrons will be there when the incident photon having energy equals to the threshold energy, and if energy of incident photon is greater than threshold energy, then work function, then there will be work of the emitted electrons will acquire some kinetic energy. That electron will acquire some kinetic energy if threshold energy of incident photon is greater. Thank you. Have a nice day.